Hello, grade 8 math. This is unit 1. This is the first lesson, 1.1. And this whole unit is about square roots and the Pythagorean theorem. Yes, that sounds like a really long word. And sometimes people get already caught up thinking, oh, I can't do this because I hear that word. But no, it's actually a lot simpler than I think the word even is. So the first thing we're going to do in this unit is look at some area models, some rectangles we have here, and we're going to move on and develop some skills that will be used in order to do this Pythagorean theorem later on in the unit. So right here we have two rectangles, and we remember that rectangles, there's two things that make a rectangle. They have to have both. First is that they are a quadrilateral. And second, that they have four right angles, 90-degree angles. Okay, so both of these things need to be true for something to be rectangle. So looking here, we have four right angles in the corner, and quadrilateral, that simply means four sides, right? Quad is four. So we have one side, two sides, three sides, four sides. Now looking at these rectangles, we'll see that this one is 1 centimeter wide. Remember, we go here and we go across, it's 1 centimeter. Remember, when we count, we're always starting at 0 and moving to the next one. So don't be like, oh, this is 1 and that's 2. No, this is 0 and over is 1, which means the opposite side, because these are right angles, would also be 1 centimeter. And the sides here would be 1, 2, 3, 4, 4 centimeters. So this one here, remember area of a rectangle is, it's a base times the height. Right? Area equals base times height. Right? It's area equals base times height. So here, our base is this bottom one, which remember, if the top is 1 centimeter, this is also 1 centimeter. So it's 1 centimeter times 4 centimeters, which equals 1 times 4 is 4. Centimeter times centimeter is centimeters squared. So that is our area in the middle here. It's 4 centimeters squared. And if you count them, how many centimeters squared there are? 1 and 1. Here is 1 centimeter squared. Here's 2, here's 3, here's 4. That's how many squares are in here. And that's what our answer is. Now looking here, this shape looks very similar, right? If we were to rotate this, it would look exactly like that first one, right? So it is a congruent shape. So these two are congruent. Congruent shapes are the ones that we could shift around and put in the same place. They have the same dimensions, that sort of thing, and the same amount of sides. So here we have one high, 1 centimeter, and then our base is 1, 2, 3, 4 centimeters. So this here would be 4 centimeters times 1 centimeter, which equals 4 times 1 is 4. Centimeters times centimeters is centimeters squared. So right there, we have two congruent shapes. They're the same shape. They have the same area. 1, 2, 3, 4. We're going to use this idea of these square units in a moment here. So let's look at this. Let's draw a square. Think about a square. I'm going to draw this one. I'm going to draw a 4 by 4 square. Actually, I'm going to use a ruler. So looking at this square that I drew with my ruler, it's 1, 2, 3, 4 high. So 4 centimeters. And the base is 1, 2, 3, 4, counting from line to line. So our area here would be 4 centimeters times 4 centimeters, which equals 4 times 4 is 16 centimeters squared. And if I were to count all the squares in here, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which is the same as this 16 centimeters squared. So the question might come up, is a square a rectangle? Well, let's look at the definition again. A rectangle is a quadrilateral. It has 4 sides. Count the sides of a square. Does it have 4 sides? 1, 2, 3, 4. Yes. And are there right angles in the corner? Yes, there's 4 right angles right in these corners. So, by definition, is a square a rectangle? Yes, it is. So a square is a rectangle. There's just one thing about it that is different, and that is that its sides will all be the same length. These will all be 4 centimeters if it is truly a square. So that's the only thing, but it is a type of rectangle. So a square is a type of rectangle that has sides of equal length. A square is a type of rectangle that has sides of equal length. So looking at this square, what did we do? We multiplied 2 numbers that were the same number. So we can come up with this new concept here. It might be something you're familiar with already, but the idea is that a square, when we say to square a number, to square a number means to multiply a number by itself, okay? This right here, this is the key thing to know for this lesson. So this right here, to square a number means to multiply by itself. So we had a number here, 4 centimeters, and we squared it. We made it into square, and that it means a number times itself. So for example, if we say something is 4 times 4, well, that actually means the same thing. It means 4, and we have what's called a superscript or an exponent of 2, right? Why is this 2 up in the air? Because that tells me this number right before it, how many times we multiply it by itself. So right here, we had 2 times that we multiplied 4, right? We have 1, 2, 4 here, and 1, 4 here. That's 1, 2, which is that. So if you see exponents up in the air like this, that means this number gets multiplied that many times. Let's do another example here. What about 11 times 11? How would that be written? That would be written as 11 squared. Let's do it the other way. What about this here? Let's take 13 squared. How would you write that spread out? It would be 13 times 13. So when you're writing these in your grid paper notebook, my suggestion is try to have the bottoms of your number sitting just on that line. And if you have to skip a line or 2 each time as you move down the page, do that. Maybe just skip 1. I skipped 2 here, but you probably only need to skip 1. And this should be smaller than these numbers, more like this one. This one's maybe a little big. Let's do another example here. What about if we won't use a lot in this unit, but it's just an idea. What about if we go 6, and then right up top here, I put a 3. What would this mean? It would mean we take this big number out front, and we're going to multiply it by itself 3 times. Okay? So that's what that means. So the number up in this guy is called an exponent. I'm going to just draw an arrow to that, and I'm going to say that that is an exponent. Okay, let's underline that. Let's make that stand out, because that is the other key thing for this lesson. When the exponent is a 2, we call it squared. Okay, that's another key part of this. When we see an exponent of 2, we call it squared. Why? Because when you're calculating the area of a square, you take a number and multiply it by itself. So if we're taking a number and we're multiplying it by itself, that is 11 squared. So that's where we get that idea of that 2. Now, I left a little space here. Why? Because we didn't actually calculate the answers for these here. So 4 times 4, what does that equal? 4 times 4 equals 16. What did 11 times 11 equal? 11 times 11, it equals, here's a trick for 11's times table. First digit, when you're multiplying 11 times anything, take your first digit, make it your first one, take your last digit, and then the number that goes in the middle is these added up. So it's 121. What about 13 times 13? Might need to do some multiplication in columns, and you get 169. There are other ways we could have figured it out. And then we have 6 cubed. What about this one? 6 times 6 is 36, and 36 times 6 is 36. 3 times 6, 18, 21, 216. Okay, so I'm going to take one of these and just put it below to explain a little thing here. 4 times 4 was 4 squared, and 4 squared is equal to 16. These numbers here that you get, so 16 or 121, 169, 216, those numbers that you get when you multiply a number by itself, this number is called a square number, or a perfect square. Which is our fourth key thing for this lesson. So just to refresh before we do maybe a couple examples of things on your assignment, the first thing you need to know is to square a number means to multiply a number by itself, just like this, 4 times 4. An exponent is these numbers up in the sky, which just shows you how many times you multiply the number before it by itself. The third thing was when the exponent is a 2, we call it squared. Just a side note, when it's a 3, we call it cubed. We'll understand that better by the end of the year. And then finally, the number, the answer that you get when you multiply these two, so the product you get, that is called a square number or perfect square. So one question that I could ask, I'm going to use one of these examples here. I could ask, 16, is it the perfect square of something? What you could do is you could start and, draw one dimension one way, one the other, and be like, okay, there's 1. I'm going to make it a square still. There's 2, 3, 4, and keep going like that. 5, 6, 7, 8, 9, not yet there. 10, 11, 12, 13, 14, 15, 16, until you get to your 16 centimeters squared, and then you know that the square root, we call it, of 16 would be 4 centimeters. So that's one way that you could figure out if it's a smaller number. So let's do some examples. Let's do this first one. What about, let's look at a square number of 144. That's a square number. Let's try to think, what would the side length of that square be? So if I drew a square, I know this isn't perfect. Should use a ruler more often. Let's do it. Voila, much better. Rulers are handy. All right, so 144 is my square, perfect square. So, sorry, we're going to find the perfect square. We have the perfect square here, 144. We're going to figure out what are the sides of 144 if it were a square. Well, let's use some ideas here. We know that 144 is bigger than 100, right? So let's say this was 144 centimeters squared. We know this is bigger than 100, and we know that 100 is the same thing as 10 times 10, right? So we know the numbers we're dealing with have to be bigger than 10. And we learned just before this that 11 times 11 was this. What about 12 times 12? Let's multiply 12 times 12. 2 times 2 is 4, 2 times 2 is 1, 1 times 2 is 2, 1 times 1 is 1. Add that up, 4, 4, 4. There we go. And if we were to take these and draw in the grids where they're a centimeter each, all 12 groups of boxes, and count it across, we would get to 144. So what's the square root of 144? The square root would be, or the side length in some ways, the side length is 12. Here's another example. There are 4 numbers written here, 16, 9, 21, 17. Which of these would be perfect squares? Which ones of these would be perfect squares? In other words, which ones could have 2 factors that are the same number? Are there 2 of the same number that can multiply to be 16? Yeah, 4 times 4, right? So this one is a square, so perhaps it might say put a box around 16 if it is a perfect square. What about 9? Are there 2 of the same digit? And I'm just going to write this in here so we remember it. They're 2 of the same digit that multiply to 9? Well, yeah, 3 times 3, which is 3 squared, right? So this one is as well. What about 21? What factors do we have here? We could have 3 and 7, right? So that doesn't work. Those aren't the same number, so this one is not. What about 17? Well, that's a prime number, so we know that that one's not. There's only 1 and 17 multiply to get to this number using whole numbers. Perhaps a question could say, what are all the perfect squares? From 0 to 100. So let's think about this. 1 times 1 is 1. So that's our first one. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. What about 0 times 0? I forgot about that one at the start. Is 0. Because it said 0 to 100, not 1 to 100. Any numbers that are in between these products here, any numbers that in between would not be perfect squares. Why? Because to get there, you'd have to use numbers that aren't the same thing, or use decimals, fractions, those sorts of things. So we're talking about whole numbers here.